demonstrate how to compile a blinking code for ATmega32 and using the Microchip tool and simulate it using Proteus. Firstly, we will begin by the blinking code itself. The first line representing what's the frequency that we choose for our CPU. For the ATmega32, we have a range of 1 MHz to 16 MHz. So here in this code, we choose the 16 MHz. Then here in this line, we include the header file, including all the libraries and all the memory declarations for the ports and registers for the AVR. So we can use it on the code, and this header representing the delay function, so we can use it for the blinking process. Firstly, we will begin our int main by determining the direction of the port that is connected to the LEDs that we will make blinking on. Blinking means that the LED will be turned on and off, and between the on and off we will put a delay so we can observe the change between turning on the LED and turning off the LED. So our LED will be connected to port C. This is the reason that we determined the direction of our bands of port C to be all output. So we use the register, which is the DDRC. DDRC means it's data direction register, and C stands for the port. So we made all output by putting on the DDRC 0xFF. 0x we put it on the beginning of the hexadecimal representation of the number, and FF means 8 ones. By this we make all the port as output. Then we initialized port C by putting 0x00, so we initialize the port C to be all zeros. Then we will begin the blinking code itself. We put port C equal. We will turn on the LED green connected to PC1, which is bit 1 in port C. So you will see here the position of bit 1. If we say the places of the port, you will see here 0, this is place 0, place 1, 2, 3, 4, 5, 6, 7. So we have 8-bit register, which represent port C from bit 0 to bit 7. So we put here a 1 on PC1, which is bit 1, to make the LED turn on. Then we put a delay function, which is called delay ms. Ms means millisecond, so we will put a 300 millisecond for the LED to be turned on. And then here in this line we turn off PC1, which is the LED, so we put here a 0, and then we put a delay. All this body we put it on a while one loop, which means that this body will be repeated forever. Let's go to compile this code on the Microchip Studio first. So we will click here this icon. It's opening. Now we want to create a new project. So we will go here for File, File, New, Project. Then here we will choose GCC C executable project, because we will write our code by C, and we want it to be executable so we can download it on the ATmega32 in the Proteus tool. Here we can write our project name. We can call it Blink1. Then observe this location, because when you want to burn the code or the hexa file that will be generated from the Microchip Studio, you need to know the location, so we can choose the file to burn it on the ATmega32 on the Proteus software. Then OK. In this step we will choose our device, which is ATmega32. You will find it here, the first one, and then OK. In this step the project is created, and now we can start our code. So we will copy this code, and then we will put it here. I think we need 2 curly brackets. Okay. Can remove this red parts. And that's it. Now we want to compile our code and generate the .hex file. So we will go here for build, then build solution, okay. So now we have error. What's the error here? That we have this red things. So if you have an error, you look here and we'll try to analyze the error that pops up, and then edit your code and then build it again. So here we will click build again, and because our code is successfully correct and have no errors, you will see here build succeeded. Now if we go to the location that our file saved on, so my file I saved it on documents ATmel Studio 7.0 Blink1 and Blink1. Then you will found here in debug blink1.hex. This is the file generated with our code that we can use it to burn it on the ATmel ATmega32 device on the Proteus. So let's go to the Proteus here to build the circuit and then burn the .hex file on. The .hex file is the file that represent different things. It's represent on zeros and ones, represents the code itself, and represent how it can be what's the device and all of this stuff. Now we will go to Proteus, open Proteus. Then here we will go to File, New Project. This is the new one. Then Next. Here you will choose Default. Next. Next. No firm project. Next. And Finish. Now you see this schematic that we will build our circuit on. So first thing, you will choose from here icon. It's called component mode, so you will click on it and then choose here P. So a combo like this will pop up. You will write ATmega32 here, 32. So the first choice here is ATmega32, and this is the preview of it as a schematic. This is on the layout, so press OK, and then here press one click. This is our ATmega32. Okay. The VCCs and ground is already connected on the background, so you don't need to connect the VCC or ground for the IC. So what we need only that we want to connect our LED. So here PC1 in bin 23. This is the bin that we used to connect to it our LED, which will be turned on and off to make the blinking code. So we want here to connect a LED, and we can't connect the LED directly for the bin. We have to connect first a resistance. It's about 100 200 ohm, and then we will connect it to our LED, and the LED we will connect it to a ground. So first we should go to search for the resistor here, P, and then right here 100 ohm, resistor, so the nearest one is the resistor 120 ohm here, so we will choose this one. All of that before this line, it's like a variable resistor, so we will not choose it. Okay, then put here the resistor 120 ohm, and then we will go to bring the LED, so we will write LED space green, because we want to turn it on green, and then we will choose this one and OK, then click here. So we want to make it on another side, so we will rotate it. So click here, and this combo will pop up. Then we will rotate it. No, that's not what we want. Okay, that's perfect. Now we need a ground, so we will go here to the terminals mode and select this icon, and then here we will select ground, and then here we will click, we will find the ground. Oh, move it here. Okay, now this is the time to connect all the components together. We will make here a wire, and here also another wire, and we will connect this to the ground. Okay, So now all components are connected successfully. We want to download or burn the code on the ATmega32. So here we will choose the icon of the selection mode and come here to the ATmega32 and make double click on it. So this window will pop up. You will go to program file here and choose the .hex file. If you open this, you'll see that this is the path of the file that I asked you to memorize. And then here we will select blink.hex, open, and then OK. So our code here, now we want to simulate it, so we can press debug and run simulation. So here the LED now is green, then turned off, and this is the blinking. And that's it. Thank you.